Hey Team Bio, welcome to your screencast on Introduction to Arrays and Introduction to the Piezo. Okay, so an array is a coding structure that we're going to use to help us organize our variables, and the piezo is a component that you're going to learn a little bit about. It's a noisemaker, a buzzer. It's the most annoying component in the kit, so I'm sure you'll all love it. Okay, what is an array? An array is an ordered list. And arrays are used to store multiple values in a single variable. And so instead of declaring separate variables for each value, we can streamline our code and declare an array. Okay, so whenever you're declaring an array, there is a way to do it. So the first thing that you need to define is the variable type. This is a new variable type that you haven't seen before, but a string is used for storing text. So far, the variables that we have mainly used, actually I think the only type of variables that we have used are ints, which are storing whole numbers. So a string is a different type of variable. It's used for storing text. Okay, that's our variable type. The second is the name of our array. So we're going to call our array cars. The third part is the number of elements in the array. So this is the number of pieces that we're going to store within our array, and if you count them up, you can see we've stored 4 here. This is 1, 2, 3, 4. But actually ignore that I just said 1 there, because you're going to see that's a little different than I just said. Okay. So we have created an array, we're using a string, we have given it a name, which is cars, and we said it's going to hold 4 elements. So the elements are all the pieces within the curly braces. And they are separated by a comma. Okay. An important thing to know is that an array is actually what's called zero indexed. Our computers actually are zero indexed. Zero indexed means that you start counting at 0. So this is important when we're talking about an array, because Volvo is not position 1, it's actually position 0 in the array. BMW is in position 1, Ford is in position 2, and Mazda is in position 3. So I'm going to create my array somewhere at the beginning of the code, maybe before the setup. So it's a global array. I can access it in any piece of my code. And then, so you're going to create the array in your code. And then later on in the code, oops, AY, you're going to access it. And how you access it is by calling the variable. So here we've written cars. And you're going to say what element you want to access within the square braces here. or square brackets, I guess they're called. Okay, so if we wrote cars 0 here, this means we want the element that is in position 0 of the array. So we are going to access Volvo with this by doing this. And if we write cars 2, this means we are going to access Ford. So you're going to be using this structure to create your own song. You're going to have a list of notes in an array, and then you are going to access the different notes when you play your song. So you'll see, it'll be kind of fun. But in order to play a song, you need to use a piezo. Okay, so as I said before, the piezo is a noisemaker, a buzzer. You actually have 2 piezos in your kit. The first is called the passive buzzer. And you can recognize the passive buzzer because if you look at the bottom, you'll see some soldering components and a little logic chip at the base. This is compared to the active buzzer, which is full of a black polymer. So you won't see any green underneath the active buzzer. So the active buzzer is nice because you can get it buzzing right away. It buzzes whenever you've connected it to 5 volts. It operates with direct current, which your Arduino is supplying. 5 volts is 5 volts DC, not AC, alternating current. But it only plays one tone. So you can't really play music with this guy. You can only have it buzz or not buzz. You can vary the amplitude. And the amplitude is equal to the volume by changing the value of your resistor in your circuit. So if you make it a bigger resistor, this guy will play more quietly. And if you have a smaller resistor or no resistor, it will be loud, loud, loud. Okay, so the passive buzzer is a little bit more complicated. So it will click when you connect, when connected to direct current. And this is because when you connect it to direct current, essentially for just a brief moment in time, if say you're operating at 0 volts and you jump up to 5 volts, this kind of acts like alternating current, right? We just went from 0 to 5. In order to actually get this to play a tone, we need to go back to 0 again, and then back to 5, and then back to 0, and then back to 5, and then back to 0. But every time you connect and disconnect it between 0 and 5 volts, the passive buzzer will start to play because it's like, oh, it's working. This is alternating current. But then it's just, if it's stable at 5 volts, it won't play a tone. Or if it's stable at 0 volts, it won't play a tone. So that being said, it will click when it's connected to DC, but it needs alternating current in order to play a tone. AC to play a tone. So we can mimic alternating current with a square wave. And if you look over here at this image that I've drawn here, you've seen this before when we were talking about analog right. We used this model to talk about how we can write a value between 0 and 255. I guess I should say 0 to 255. Actually, it's pin number. And then 0 to 255. And this is determining the duty cycle, right? So if we have a duty cycle of 50%, this means that we're writing a value of approximately 127. Okay, so we can mimic an alternating current with a square wave, and changing the frequency of the square wave changes the pitch. Now, it's possible to do this with analog, right? However, it's much easier to do with a built-in function in the Arduino program called the tone function. So there's a built-in function that does this for you, and it's called tone. Okay, so the arguments of tone, first of all, the way I've written it makes it seem like it's uppercase, but it's actually all lowercase. The tone function takes 3 arguments. The first argument is the pin number. You have to tell the Arduino where you want to play the tone. The next is the frequency. And this is a number in hertz. Hertz is a measure of the pitch of something. And so any note that you want to play, you can look up the frequency in hertz and then write it down here. In the sketch that I give you, the frequencies for all the notes are already predetermined, or they're pre-written down for you. The easiest way to do this is to just copy and paste a big list of notes with their frequencies and have them predefined for you at the top of your sketch, which you'll see in the next sketch that you look at in class. And then the last argument, which actually you don't even need to include, but you can include, is the duration. So this is an argument that you can provide. But don't need to. And the duration is going to be in milliseconds. Okay, so the last thing I guess I want to say is that if you want to stop the piezo from playing a tone, because you haven't provided the duration, for example, you can, and also the tone function just glitches all the time. It's very annoying. And often if you're trying to use tone and do other things in your code, you get errors. And that's in part because the tone function uses the built-in timer on the Arduino, and it just is complicated. But the sketch you're going to work with tomorrow in class works just perfectly. But when you're trying to build things from scratch, sometimes the tone function can be tricky. Okay, so if you want something to not play, you use the function no tone, where the T is capitalized. And then the only argument for this, there's one argument, and that is the pin number. Okay, so the piezo is kind of working similarly to the DC motor, actually. You're going to have a coil of wires. You're going to have some permanent magnets. And when you run a current through the coil of wires, this is going to create a changing electric field and magnetic field, and that's going to take this this metal weight basically is going to be oscillated up and down, and then these oscillations are going to create waves in the air, and then that is sound. So that is how the piezo works. Okay, that's all. See you in class on Thursday.